morning, good afternoon, good evening, whatever the case may be. We are back and better than ever to the great Beach Boys. So we shall continue and talk about tangents and normals. You can argue that the surfboard is tangent to the wave. Yes, yes. How about that segue? All right, let's get right to it, shall we? All right, we're talking about tangents and normals. What are tangents? Well, we've talked about tangents. I'm not sure if we've talked about normals yet. But a tangent line is a line that touches the curve in one place, like this little green line right here. And a normal is a line that is perpendicular to the tangent line at the point of tangency. So here's the point of tangency where the tangent line touches the curve, and then you see the normal is perpendicular to the tangent line right there. And what we are going to do today is find the equations of a tangent line to a curve at a particular point, and also of a normal. And we'll start with the tangent. So find the equation of the tangent to f of x equals x squared plus 1, where x equals 1. Well, the curve, let's just do it real quick. X squared plus 1. You don't have to do this. I'm just kind of giving you an idea of what we're talking about. It's a parabola, and it looks something like that. That's not too bad, huh? Not too bad. F of x equals x squared plus 1 at the point where x equals 1. Okay, so the tangent is a line. So in order to find the equation of a line, I need the slope of the line, and I need a point on the line. Okay, so let's take care of the point on the line first. We know that the tangent line is going to share this point with the curve. It's going to be on the tangent line and on the curve. So I can easily find a point on the line. I know that x is going to be equal to 1 because that's what I'm being asked here, to find the tangent when x equals 1. So to find the y-coordinate, I just substitute into the original function. So the y-coordinate is just going to be f of 1, which is equal to 1 squared plus 1. All I did is I took the 1 and I replaced the x with it. 1 squared is 1, plus 1 is 2. So it's going to be at 1, 2. And I'm just going to graph that real quick, which makes sense. There it is, 1, 2. It's right on the curve. And so that tangent line is going to go like this. Okay, so now all I need is the slope. How do I find the slope? I take the derivative, because the derivative gives me the slope of the tangent to the curve. And if f of x equals x squared plus 1, f prime of x, the derivative, is equal to simply 2x. Why is that? Well, remember your rule. To find the derivative of a polynomial with an exponent, I just multiply the front of the term, or the coefficient of the term, by the exponent. There's a 1 here, so 2 times 1 is 2. And then I subtract 1 from the exponent, and 2 minus 1 is 1, so it's 2x to the first power, but we don't write that first power, we don't have to. So to find the slope when x equals 1, I just replace x with 1 in the derivative, so that's going to be 2 times 1 equals 2. So I have a point on the line, which is 1, 2, and I have the slope. So I'm going to use point-slope form of a line to write the equation. Point-slope form. And that form is y minus y1 is equal to m times x minus x1. Okay. Remember, m is your slope, yes, and then x1 and y1, these guys are the coordinates of the point we found that's on the line, the point on the line. Okay, so very simple, very easy. Y minus y1, so that y1 is 2 here, so this is my y1, This is my x1, and 2 is my slope. Okay, so y minus 2 is equal to 2 times x minus 1. And we're going to put this in the form of y equals mx plus b. It's easier to graph that way. So y minus 2 is equal to 2x minus 2, right there, distributing. And if I add 2 to both sides, plus 2, I end up with y equals 2x. Okay, so y equals 2x. I got 2 points here, and I'm going to try and graph this when x is 0, y is 0, when x is 1, y is 2. Okay, and so let's see how I do graphing it. It's going to be tough. Not too bad for a drawing. So that's what it's going to look like. That's the tangent line. Okay, so let's just take a look at the calculator, x squared plus 1 and 2x, just to get a better picture of it. So here is x squared plus 1. Okay, and then I'm just going to move that out of the way, and I'm going to get a point up the line when x equals 1. So a little bit geometry, points and lines, and point on. So I want a point here. There we go, and then I will just change that to 1. Okay, and then we claim that the equation of the tangent to the curve when x equals 1 is 2x. Let's see if we're right. Of course we are. And you can see how it touches the curve in exactly one point where we wanted it to, at x equals 1. All right, one more problem. And that is y equals, I'm not going to do the graph for this one. We'll just do it on the calculator. So y equals 8 over square root of x, we're at the point where x equals 4. So in order to find the equation of a line, and this is the normal now, we'll talk about how we find the slope of that. We still need the slope, and we need a point on the line. Okay. So the point is 4, and then the y coordinate is going to be 8 over the square root of whatever x is. Well, x is 4. 8 over the square root of 4, which becomes 8 over square root of 4 is 2. So that's going to be 4. Nice. So it's at the point 4, 4. Okay. Now I need the slope. Well, in order to get the slope, I need the derivative. So I'm going to rewrite this as 8 over x to the 1/2 power, which is equal to 8x to the negative 1/2. So that I can take the derivative of. So that becomes negative 1/2 times 8x to the negative 1/2 minus 1, and since it's a denominator of 2, I'm going to rewrite that 1 as 2 over 2, just makes it easier. So y prime equals negative 4x to the negative 3/2, okay, which is equal to negative 4 over x to the 3/2. Okay, and there's a couple other ways we can think of it. This is equivalent to negative 4 over the square root of x cubed. Okay, or you can just do it in your calculator. So in order to find the slope, I need to find y prime of wherever we want to find the slope at, and x is going to be equal 4. So I need y prime of 4, which would be negative 4 over 4 to the 3/2 power, or 1.5. And you can do that on your calculator. You'll be able to use a calculator for this. Or you can figure it out in your head if you want. So I'm just going to add a page, a calculator. So that's going to be 8 over, and make sure you get this right. Oh no, I'm sorry, it's negative 4 over 4 to the 3/2. Sorry about that. So let's go back. So negative 4 divided by 4, and you need the caret, to the 3/2. And let's see what we get. We get negative 0.5, which is negative 1/2. Okay, so this is equal to negative 1/2. Now that is the slope of the tangent. Okay, the slope of the tangent. We need the slope of the normal. So I'm going to ask you to recall slopes of perpendicular, that's the symbol for perpendicular, lines that meet at a right angle. Perpendicular lines are negative reciprocals. Negative reciprocals. So the slope of the normal is a negative reciprocal of the slope of the tangent. So that implies that the slope of the normal is equal to 2. Why? Because the reciprocal of 1/2 is 2 over 1 or 2, and it's the negative reciprocal, so if I take the negative of a negative, it becomes positive. Okay? So now I have my slope, I have my x1, I have my y1, so I can easily use point slope form. Y minus y1 equals m times x minus x1, and now it's just a matter of substitution. Y minus 4 is equal to 2 times x minus 4, and get it in y equals mx plus b form so we can graph it. So y minus 4 equals 2x minus 8, distributing the 2 through. I add 4 to both sides, and I get y equals 2x minus 4. Okay, so let's take a look and make sure that that is correct, or at least it looks like it. So let's see, y equals 8 over square root x. Need a new page, new graph. So first we're going to graph the function, right, or 8 over square root x. So there's the curve. Okay. And our claim is that the slope is equal, the normal is 2x minus 4, and at the point 4, 4. So let's go ahead and graph that point. Again, menu, geometry, points on line, point on. So here, I'll put a point on there. Ooh, I was pretty close, eh? So let's make it 4, 4. Oops. 4. All right, so it's 4, 4. So what do we expect? Well, we expect a line to go through that would be perpendicular to the tangent line. And again, we claim that that line, the equation of that line is 2x minus 4. So let's go right back to it. 2x minus 4. And there we go. Does that look to be perpendicular to the tangent line? Well, let me just quickly put the tangent line in there. Menu, geometry, points and lines, and I'm going to do a tangent line. So it's waiting for me to do the point. And there we go. Let me get that nonsense out of there. If I pull this tangent line, it certainly is, appears to be perpendicular. We know it is from the calculus. So this pink is our solution. Y equals 2x minus 4 is the line that we are looking for. So that is it. Hope you enjoyed it. Sorry about that. And we are going to be out as soon as we get a little bit more of the great Beach Boys. See ya!